Hello student, the topic is surface flow over the channel and subject is hydraulic engineering. My name is SONU SINGHAL and I will teach you the unit 4, that is surface flow. Okay. So in this diagram we can see that this is the a rectangular channel and the flow is over it, and discharge Q is mentioned in the channel is W into du into u. And in the next figure, this is the shows the velocity according to the vertical and horizontal distance on the channel. So we can see that the velocity is increased as the channel is length is increased. Okay. Now next is hydraulic radius and roughness parameter. It is a measure of contact area is the hydraulic radius r equal to A upon P, where A is the cross section area and P is the weighted perimeter. Many measure of roughness. Most common are Manning's roughness parameter, Chase's constant, Stigler constant and friction factor. Manning roughness parameter most fully dependent on roughness alone, bed properties, not channel geometry. Right? Now we can see this diagram. This is the example of the weighted perimeter and hydraulic radius to calculate, and this is the rectangular channel, that is the height of 2 feet and that is the length or width is 20 feet. So we can calculate weighted perimeter and hydraulic radius, right? And we can also calculate velocity in this channel if the discharge is 400 feet cube per second. So the discharge equal to area into velocity. So first of all we find out the area, right? And after that we can find out weighted perimeter, right? So this is the example of weighted perimeter, right? Now we can see this diagram. The first is so laminar flow and second is so turbulent flow. So we can observe the flow in the channel this type, and in the next uniform flow that does not change with the distance downstream, neither in area nor velocity. Varied or non-uniform flow, right? Flow that changes with the distance downstream, that is the non-uniform flow. And we can see this diagram for uniform and non-uniform flow, right? This is the bed and flow suddenly increase with the changes velocity. Speed of water. Uniform flow easiest not changing, that is equal to forces are zero. What does it steam like the speed of water in a channel will depend on gravity, gradient and some measure of resistance. This it turns out related to the area of the bed and a measure of the properties, mostly roughness of the bed material. And next is the that is the diagram of friction force and drag force. We can understand why this diagram drag force, and we can measure volume of water moved per time, that is V equal to U into AC, where AC is the area of cross section, right? And in the next is friction factor. Friction factor F characterized the overall effect of the shape of the bed particles in the counteracting flow motion. Friction varies with the change from drag to the skin friction, right? FF is the dimensionless numbers, right? And what does its value depend on? F equal to F. So PF equal to FF AP arrow UQI 2. Then the next, balance of gravity and friction forces. Balance to get velocity for uniform flow, that is, we know that F equal to ma, and total force is gravity force minus friction force, right? If total force is 0, that Fg minus Ff equal to 0, Fg equal to Ff. So these forces are equal, right? And this is the value of gravity force, that is Pf upon u. And after solving this, next is gradually and rapidly varied flow. Uniform flow doesn't occurs everywhere. Gradually varied flow occurs where stream depth and speed change smoothly. Rapidly varied flow occurs when where stream depth and speed change suddenly. In gradually and rapidly varied flow, it is a rather complicated calculation to find the speed, right? It's need to look equation or motion a bit and perhaps use a numerical program. The next is one can map out the reaches of any stream such as the Niagara rivers defined by stages of uniform flow and separated by short stretches of gradually varied or rapidly varied flow. Next is to analyze the motion in these changing states. Manning's equation and its assumption do not hold. So guys, this is all about of gradually and rapidly varied flow, right? Thank you.